Hi students, welcome to chemistry online classes. In the previous class I discussed about little bit about Bronsted-Lowry acid-base theory. According to this Bronsted-Lowry theory, acid means proton donor, proton means H plus ion, base meaning proton acceptor. Neutralization reaction is transfer of proton from acid to base, that is called neutralization. Already I discussed one example, maybe once again I am discussing HCl aqueous plus H2O liquid, then this will gives H plus aqueous Cl minus aqueous. Correct? Sorry, I have to write this is when H plus donated to this will be converted to H3O plus aqueous. If H2O not there, we can write directly H plus also, because H3O plus also we can write, H plus also we can write, no problem. But now H2 is there, compulsory we have to write H3O plus. Acid meaning what is the proton donor. This is donated proton to this, that's why it is converted into Cl minus. Proton donor is acid, proton this is accepted, therefore this is base. A acid donate the proton and convert into conjugate base. Conjugate base, simply it is represented as Cb, conjugate base. Next, base mean proton acceptor. When it proton accept and it convert into conjugate acid, simply it is represented as Ca. Once again very clearly, because this part is not only in this chapter, it is important. This is important in organic chemistry also, there it is more important. So you have to remember this concept is very important. Keep in mind, acid donate the proton and convert into conjugate base. If you don't know, only listening is not important, you have to note on this line, acid donate proton and convert into conjugate base. Base accept the proton, convert into conjugate acid. Okay, so now keep in mind, acid lost proton convert into conjugate base. Base accept proton and convert into conjugate acid. Conjugate base having one proton less, conjugate acid having one proton more. So that also we can observe here. Now one more thing here, if according to this equation H2O is base, one more equation ammonia, this is aqueous and water gives rise to, this is according to this one, ammonia generally basic nature, then it is given H plus to this, so proton donor is called acid, proton acceptor is base. Now if it is donate H plus to this one, then this will be converted into NH4 plus aqueous, this is liquid. And this is when donated H plus to this, then one OH minus is there, then this is OH minus aqueous. Now keep in mind, forward reaction this is acid, this is base. Here it is backward reaction, mean this is acid, this is base, mean this is reverse. These are the reactant, these are the products. Same thing, this is converted into conjugate base, accept the proton and convert into which one? Conjugate acid. So this base accept the proton, convert into conjugate acid. Now acid donate the proton or lost proton, then it convert into which one? Conjugate base. So remember this point, very important. Now according to this equation H2O acid, according to this equation H2O base. So based on these two equations, based on the above equations H2O is amphoteric. Amphoteric means having both character, acid character and base character. If you don't know, note down here, acid and base character. Amphoteric meaning. Clear? So H2O act as a acid also, base also. Now according to this equation, now consider this is strong acid, then this is weak conjugate base. So this is very, very important. First we should know that what is a conjugate acid base pair. This is important for board level. Now anyway, exam not there. Therefore conjugate acid base pair, very, very important, and based on this many organic equations will be there in first year also, second year also. You have to remember this conjugate acid base pair. The acid and base pair differ by only one proton. Once again I am writing here, the acid and base pair, or you can write the conjugate acid base pair differ by only one proton. That is called conjugate acid base pair. Now I am writing some species here. H2O, ammonia and H2SO4 and what do you call it? H2S. Like this, some examples are given, consider. Otherwise this is also HCO3 minus. These are the some species. Then what you have to write? Conjugate acid, conjugate base. Acid meaning what is that? Acid lost proton gives a conjugate base. Now conjugate acid meaning what is that? It accepts the proton. To this if you add proton, then this will be converted into H3O plus. See, conjugate acid meaning what is that? For a base accept the proton, convert into conjugate acid. Then it is base or acid, we don't want to consider. Now we have to write conjugate acid. To write the conjugate acid, this should be accept the one proton, then it convert into conjugate acid. Now observe these two species. This is base, this is acid, because H2O act as acid also, base also. Therefore now in these two species, what is the difference? 1O, 2 hydrogen, here 3 hydrogen. How much difference is there? Only one proton difference is there. So this is called conjugate acid base pair. Now this is a species, then it's conjugate base. Conjugate base meaning what is that? Acid lost proton, then it converts into conjugate base. Now if it is acid, lost proton mean what you have to write? OH minus. Okay. Now this is a species, we have to write the conjugate acid mean one proton add, then this will be converted into NH4 plus. When you want to write the conjugate base, remove one proton, then this will be converted into NH2 minus. Here if it is conjugate acid, then possible, 1 minute, I want to write one small mistake I wrote here, HSO4 minus. If you H2SO4 write, one more H will not added to this one, that's why not, that is H2SO4 is not correct representation. Now HSO4 minus, then add one H, then this will be converted to H2SO4. Remove one H, then this will be converted to SO4 minus 2. Here H2S, possible? H3S plus like this, but it is rare cases, and this is HS minus. This is and this is similar case, therefore H2CO3 and this is CO3 minus. For example, OH minus given as a species, to write its conjugate acid mean add H plus, then this will be converted to H2, remove H, then this will be converted to minus 2. Okay. Now based on this, what you concluded, some species act as a both acid and base. Clear? Now it is act as a acid also and base also. Why? When you remove this H, then this is converted to conjugate base. It is base, means this is acid. When you add H plus, then this is converted into which one? Conjugate acid. This is acid, means this is which one? Base. So some species act as a base also, acid also, according to this Bronsted-Lowry acid-base theory. Now I will give some example. You have to write. This is HClO4 and HI, HBr, HCl, H2SO4, HNO3. These are the some acid. Then write, this is acid. Then write conjugate base. Acid, write conjugate base. Meaning this is ClO4 minus I minus Br minus. How to write? Remove H, remaining part you have to write. Cl minus HSO4 minus NO3 minus. These are the strong acid. These are only the strong acid. After this, its continuation here, acid and conjugate base. So what are the acids are there here? For example, H3O plus. H3O plus means remove H plus, then this will be converted to H2O. Next, HF minus HNO2, NO2 minus. Up to here only strong acid, remaining are weak acid. Next, organic acid, formic acid, this will be converted to HCOO minus. Acetic acid, CH3COOH, then this will be CH3COO minus. NH4 plus, then this will be converted to NH3, and here H2O, then this will be converted to OH minus. This is NH3, this is converted to NH2 minus. So keep in mind, this is actually board space not there, that's why I wrote there. So from this line up, this up line, acidic strength increases. Acidic strength increases. Here down, conjugate base strength increases, because if it is strong acid, then it gives a weak base. Therefore, based on this statement, you can write here same. This is total one vertical column, acid, conjugate base. So from down to up, acid strength increase. Top to bottom, conjugate base strength increases. Therefore, based on this statement, I want to write strong acid gives weak conjugate base. It is vice versa. Weak conjugate base gives a strong acid. Reverse also this is. And strong base gives weak. Base gives which one? Acid. Conjugate acid. These are vice versa. Vice versa means reverse also. Weak conjugate acid gives a strong base. Okay. So based on this, organic chemistry concepts are interrelated. We have to remember these statements, very important. So now we know that what is the acid, what is the base. But in this strong acid, strong base meaning acid means proton donor, which is more strongly donate. It means easily donate, that is strong acid. Base mean which is easily accept the proton, that is strong base. Strong acid, strong base meaning according to this Bronsted-Lowry acid base theory, meaning what is there? Which is easily donate the proton, that is strong acid. Which is easily accept the proton, that is a strong base. Now we can consider according to Arrhenius theory and Bronsted theory. if you both compare, then you will get the some relation. What is the relation? Base meaning what is there? According to Arrhenius theory, the species which produce the H plus OH minus ion in aqueous solution, that is a base. The species which produce the H plus ion in the aqueous solution, that is acid, according to Arrhenius theory. And according to Bronsted theory, what is the base? Base mean proton acceptor and acid mean proton donor. Now consider, this is the base. This is a base. In aqueous solution it produces the OH minus. So according to Bronsted theory, this is a base. According to Arrhenius theory also, this is a base. Acid mean what is there? Which produce the H plus ion or hydronium ion. Here same is there. So based on this, what you conclude here? All, here one statement very important. All Arrhenius acid base or Bronsted acid bases, but few Bronsted acid bases, are not Arrhenius acid base. This is a very important. All Arrhenius acid bases are which one? Bronsted acid bases, but few or may not be Arrhenius acid bases. Okay, so now according to this, ammonia is there. Now ammonia, according to this theory, why here I wrote this is ammonia is base, but according to what you call Bronsted theory, do not produce the OH minus ion. Therefore, that is a limitation also is there. So due to that limitation, ammonia is, according to that Arrhenius theory, not base, but according to this theory, this is a base, because base means proton acceptor. Okay. Next. Okay, now limitation of Bronsted-Lowry theory. Limitation. What are the limitation? Now consider AlCl3, BF3, CO2 are acids, but do not explain their acidic nature, because according to this theory, what is there? Proton donor is acid, but these do not donate the proton. Therefore, actually these are acid, but according to this theory, these are not acid, These are not acid. Next, those who donate those who accept the proton, they are called base. Now calcium oxide is there. Calcium oxide is basic nature, but do not accept the proton, therefore do not explain its basic nature. Do not explain its basic nature by this theory. So it has some demerits. Therefore we are going for another new theory, that is called Lewis acid base theory. Lewis acid base theory. According to this theory, acid, what do you call, pair of electron acceptor. Pair of electron acceptor is acid base, meaning pair of electron donor. Neutralization is pair of electron transfer from base to acid. Neutralization reaction is pair of electron transfer from base to acid. That is called neutralization reaction. For example, H plus is actually hydrogen atomic number we know, hydrogen 1, electronic configuration 1s1. H plus meaning what is that? 1s0, atomic number 1. It means no electron. It is empty orbital. This is empty orbital, no electron. When it is empty orbital, then it can accept the electron. Pair of electron acceptor. When it is accept, when pair vacant orbital is present. So this is having vacant orbital. Okay, now I am writing here ammonia. Ammonia means it having the one lone pair. This lone pair given to this, then this will be represented like this. It means this pair of electron present in between this nitrogen and hydrogen whole power plus, because one plus is there here. Okay, now this can be simply represented as nitrogen, and 1 plus 3 4, this is 4. So now consider this electron donated to this H plus, this is arrow mark towards the H, mean it is negative, this is positive, negative, positive, neutral. But this nitrogen is lost, therefore it is plus. Already you know in organic chemistry, from where it goes, that is from where it is coming, that is positive, where it is going, that is negative. So here positive, here negative, negative, positive, neutral, this will be get the positive. So this can be represented like this on nitrogen plus. This is called ammonium ion. This is called ammonium ion. And it is donating electron pair to H plus, therefore this is Lewis base, and this is called Lewis acid, proton acceptor, this is Lewis acid. So like this already you studied in organic chemistry also. In between this is which bond will be there? Coordination covalent bond is there. This pair of electron is belongs to both now, but which is donated? Nitrogen. Already you may be studying the chemical bonding chapter also. So contribution of electron by one atom, but sharing of electron by both the atom. So in between this which bond is there? Coordination covalent bond is there. So this can be represented like this also. NH3 donating electron from nitrogen to hydrogen. When arrow mark is denoted, there is no positive negative charge. It indicating donating from nitrogen to hydrogen. This is called which bond? Dative bond. This is also called dative bond or coordination covalent bond. Okay. Similarly, one more example, H plus, and this is water molecule. This H2O, you can write like this also, because here otherwise if you confuse, then I will write as usual also H2O. Now here two lone pairs are present. Then this will be gives to this H plus and form like this. I will write H2 plus 1 H3O. So one lone pair lost, one lone pair is present. So when it is lost, this positive, here negative, negative, positive, neutral. So one positive charge we are getting. Its name hydronium ion. Hydronium ion. Similarly, N, this is called Lewis acid. L acid means Lewis acid. This is Lewis base. Similarly, ammonia plus BF3, it having one vacant orbital. How we can conclude this concept? Boron atomic number 5, 1s2, 2s2, 2p1. So here 2 electrons are present, here 3 orbital 1. In excited state, this electron comes to here. In excited state, ES means excited state, this electron jump. Then one vacant orbital is there. 3 unpaired electron, 3 bond form with the fluorine. Then 3 fluorines are there. One vacant orbital is there. So now it is donating to this one. Then it form like this adduct. This is called adduct addition. This is therefore adduct. This is therefore NH3BF3 like this. So this is adduct. What do you call this? Is adduct. Now accepted, this is therefore Lewis acid. This is given therefore Lewis base. Now totally based on these 3 example, what you concluded, to become a Lewis acid, it should contain vacant orbital. Then only it accept the pair of electron. To become a Lewis base, it should contain at least one lone pair of electron. Then only these are at least one lone pair. Then only these are converted into which one? Lewis base. Then only they will donate the pair of electron. Now based on this, I will conclude the some acid and base. Acid, base. Lewis acid, Lewis base. So what are the Lewis acid? They should having the vacant orbital. When they having the vacant orbital, when they having the positive charge. Already you know in organic chemistry, carbocation is having empty p orbital like this. Any metal ions, H plus, Mg plus 2, Fe plus 2 like this, cobalt plus 3, etc. Positively charged. Organic chemistry ions are carbocation, CH plus 3, C2H5 plus like this, any one that is called primary carbocation, secondary carbocation, tertiary carbocation or acid, positively charged or acid. Otherwise like this, BF3, AlCl3, FeCl3, ZnCl2, SnCl4 like this also act as acid because they having the vacant orbital, maybe p orbital, maybe d orbital. These are d block element, therefore they having vacant d orbital. These are p block element, therefore these are having the p orbital. Anyway, that should having the accepting electron pair, then they should act as a acid. Now CO2, SO2 is there. Here no vacant p orbital, but also these are acid. Reason, now consider like this CO2 structure. Now this can be any electron pair donor. For example, this is B is a base, consider this electron pair donor. It having one lone pair. Anyone, generalized form I wrote, B mean base, electron pair is present. When it donate here, first it move like this, because already you know that pi bond move towards the more electronegative atom. When it move, this is negative, this is positive. Already do not having the positive charge, but it having positive charge after delocalization of pi electron. Therefore it means that pi bond shifted towards the more electronegative atom. Now it is accepted. So these are also act as a acid. Now base mean what is it? Negatively charged. It's opposite. Negatively charged are bases वो